In this video, we're going to take a look at the relationship between the rate constant and the K value, the K constant for equilibrium. So suppose that you had this reaction over here, right? This A plus 2B produces 3C plus 4D. It's a reversible process. And so let's say that going left to right, we had this is our elementary step or slow step. Left to right would be the forward, FWD. The rate of the forward reaction, we can just say RF if we want, would be equal to, if we're making a rate law, little k, and we'll call this little k forward. A times B squared. We're assuming that that's the slow step. Let's just say that, okay? Now, we could also have a reverse. The reverse would be going this way. So rate of the reverse is equal to k reverse, little k reverse, that's the rate constant, times C to the power of 3 times D to the power of 4. Now, if these are at equilibrium, what we know is that these are actually equal to each other. So at equilibrium, rate of the forward is equal to rate of the reverse. And so we can actually write that out. We can write that k, little k, forward times A B squared is equal to little k reverse C cubed D to the power of 4. And so what you can do is you can actually rearrange this and get an interesting ratio. If you rearrange it so that your k's are all on one side, so let's say we send this to this side here and this to this side here, you get k forward over k reverse is equal to C cubed D4 over A B squared. In other words, this is your products over reactants. This K forward over K reverse, it's basically absorbed into one constant. So when you do your products over your reactants, that's basically your rate constant for the forward over your rate constant for the reverse, and that is your K EQ, your K equilibrium. That's what that is. That's what that ratio is. That's where it's derived from. You don't have to do this every single time. Just know that this K value kind of is an incorporation of this rate idea. And the reason that KEQ is affected by temperature, as you would have learned, is because, well, rates are affected by temperature, right? So that's kind of the general idea behind where KEQ comes from. Again, you don't have to do this every single time. It's just showing how it was derived, how it was sort of developed, and what the meaning of it is and how it relates to rates and that little rate constant that you know about.